So the key ideas we're going to be using here, especially if we notice it's a diagram and more than one mark is a free body diagram, Newton's laws, and our approach is going to be winner minus loser equals ma. First thing I'm going to do is put my name on it. Of course, we'll go with my favorite student. All right. Number 1, an object is pulled at a constant speed by a horizontal force as shown in the diagram below. What's the coefficient of friction between the object and the surface? This is already a tough question. I didn't throw you an easy one right away. There is a key phrase in here that makes my physics ears perk up and go ding, 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 ding. Does anybody see what the magic or the key phrase that's going to help me solve this is? Constant speed. In fact, I would probably underline that just to remind myself. I'm going to do a free body. Actually, I'm not going to do a separate free body diagram. No, I'm going to label the picture that they gave me. So I'm going to go like this, and I'm going to say, okay, what are the forces acting on this object? Get the obvious one. Okay, so I have mg down. I always start there because my question's no longer blank, and sometimes kids so want to get into the weirder esoteric forces that they forget the obvious ones. And this gives me a system, because now I can say, is this object sinking into the ground like quicksand? Is it lifting into the air like Superman? So in this case, there is an equal force up. What do I call that one? The normal force. I definitely have an applied force of 12 newtons. This can't be it. What else is there? Friction. Now, I know there's friction, first of all, because they're asking me to find the coefficient of friction. They're saying, hey, what's mu? I don't know, what's mu with you? They're saying find mu. Also, though, this would be an impossible diagram for a constant speed. I have unbalanced forces. Friction. You okay with that? Who's winning? Actually, it's going to end up being a tie because of that constant speed. But if you didn't see that, you might have gone like this. Applied minus friction equals ma. You might have done that, and that's not wrong, but then you would say because it's a constant speed, a is 0. A is 0. So what you would really end up with is or Oscar, if you were really clever, you might have just plussed the friction over to this side, and if you did that, you'd get that. And some of you may have gone there right away, to which I say, great. The applied is 12. Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look, 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 look. I know the force is the same size as the normal force. Which force is the same size as the normal force? Gravity. So I can say this. I can say 12 equals mu mg. What's this question asking me to find? What's mu? I don't know. What's mu with you? No, it's asking me to find the coefficient of friction, which is a symbol, mu. How would I get the mu by itself? Divide mg. So if I hear you correctly, my friend, you're saying 12 divided by mg, 12 divided by 5 times 9.8, 12 divided by 5 times 9.8. 0.244. You know what? The answer is A. 2 marks for a multiple choice question. If you got the right answer, 2 out of 2. If you got the wrong answer, but you managed to come up with either this equation or that equation, I'll give you 1 mark. Oh, and I like that question. I like that question. I like that question. It's a nice twist. Instead of saying find the acceleration, I'll say find the coefficient of friction. Number 2, a freely falling object experiences a force due to air resistance of that. What's its acceleration? Any thoughts on how I might want to start this? I think I'm going to do a free body diagram. There it is. What are the forces acting on it as it's in free fall? Get the obvious one. Gravity. What else? Well, this question mentions one more. Air resistance. Which way am I going to point air resistance if we're accelerating down? Up. And you'll notice, Noah, I drew air resistance short. I'm pretty sure stuff falls down and still accelerates. Air resistance is pretty much always going to be the loser. Sorry, I should take that back. For a non-aerodynamically, like a parachute air resistant actually ends up being a tie. But this doesn't mention anything like that, so I'll assume it's a loser. So Noah, who's winning here? Yep, winner minus loser equals MA. Noah, what did this question want me to find, my friend? Oh, the A. How would I get the A by itself? More specific, by? Yeah, nice. So if I hear you correctly, and I think I do, you're saying that? And is it okay? I'm going to put the A over there because we're used to seeing stuff on the left-hand side. Double check. Do I know the mass? Yep. Do I know G? Yep. Okay, I can plug and chug. This is going to be 0.62 times 9.8 minus 1.4. I don't need to, they gave me the force. I'm not multiplying it by a mass or anything. That's a force in newtons. Divided by 0.62. I get an acceleration of by the way, more than one number on the top. Got to put the top in brackets. Yes. Do you get 7.54? Did I? Yeah. 7.54 meters per second squared. Oh, and it's acceleration. If you got that, I would give you 2 out of 2. Otherwise, I would probably go something like this. I would give you a half mark if I saw that line. I would give you a half mark if I saw that you got the A by itself. I would give you a half mark for plugging in the numbers, and then I would give you a half mark for the answer. Oh, and if you forgot the units, I take a half mark off, so make sure you put the units. There's your 2 marks. But again, Spence, if you got the right answer, 2 out of 2. Jen, by the way, if you haven't figured it out, because we haven't done that many tests because we started late and we've been interrupted by holidays and things, for written questions, I glanced through your work. If you got the right answer, I basically quickly skim up. You'll get full marks if you get the right answer, and you showed me some work. Now, if you get the right answer and it's blank, I get suspicious. I had a kid about 4 years ago in Physics 12 who kept writing on these really long questions that took like 9 lines, only an answer. It's pretty obvious he was cheating. So when I asked him to show me his work, he couldn't, and I told him from now on I wanted to see work, and his grade went down. Anyways, don't be one of those. That's a key word. Oscar, what word did I underline?
Net.
Net. When I say the net force, and I haven't really emphasized this the way I should, Justin, don't write this down. When we're going, it's always this side is F net, except what have we replaced F net with? What do we always write on this other side here? MA. So in other words, when I say find the net force, you can jump straight to saying, I would start there. No, free body, because they're giving me the right-hand side now. Did they give me the mass? Yeah. Did they give me A? Sorta. Sorta. I think I'm going to have to calculate A. By the way, also, this is 2 marks, probably going to be a multiple step question. So I said, okay, VI is 0. Oh, you know what? This is stuff from last unit. VF is 15. D is 8. And I'd like to find A. Even though this question, Kyle, said find of my time finding the acceleration. And that's really what this question is going to make me do. I'm looking for an equation that has an A, a VI, a VF, and a D in it. I bet you there's one on my handy-dandy formula sheet. Can you get the A by itself for me now? Maybe we're at the stage where we can redo them in our head. Yep. 15 squared minus 0 squared. I probably didn't need to write the 0 squared, but I'll show you that it's, because 0 squared is 0, but I'll show you that it's there. All over 2 times 85. The acceleration is going to be bracket 15 squared minus 0 squared divided by 2 times 85. This thing has an acceleration of, not very fast, 1.323. I'll write down 1.32. But I'll use my answer button. 1200, 1.32 times 1200, 100, and I get 1588 point, you know what, I'll call it 1600, I'll round off, or you can say 1590. Really, oh, by the, well, how many sig figs? Don't say 4. How many sig figs? 2. 2. You know what, I should probably go to 2 sig figs. So I'll go 1600 what? It's a force. Newtons. If you got that, 2 out of 2. Otherwise, I'd probably give you half mark for that. I'd probably give you a half mark if I saw that you'd got the A by itself. I'd give you a half mark for finding the acceleration, and then a half mark for the answer. Probably something like that. Number 4. A 12 kilogram block initially at rest, you know what, that's important, I bet, is pulled 16 meters across a floor by a 56 Newton force. Oh, Colin, what does this question want me to find? VF. How many marks is this one worth? You know what? If I'm a good test writer and all the other ones have been worth 2 marks, I'm thinking maybe this is a 3-step question. Maybe this is going to be a trickier one. So I'm not going to panic. I'm going to expect it. I know what's coming around the pipe. Okay. What did you say they want me to find, Colin? I'm going to write down. Oh, they said at rest. They also said you know what? I think if I can find that, then I can use the one that you rattled off earlier, Deb, VF squared equals VI squared plus 2AD. So, Colin, although this question is saying find V final, what am I going to spend most of my time finding? Acceleration. How? I bet you forces. So I'm going to draw a little line right here, and I'm going to do the acceleration on the right-hand side. Be kind of organized. Oh, they gave me a picture, so I'm not going to redraw the free body diagram. I'm going to say, okay, I got the obvious one, gravity down, normal force up. I have an applied force, and they're talking about a coefficient of friction, so I got friction. Who's winning? Really? Gotta be. Otherwise, this would be kind of, there's no way it could be moving 16 meters across the floor. If friction was bigger, what that would really be saying is you're pulling and it ain't going anywhere. Okay? Like, hey, try pushing against the school. Friction is big enough. It's not going anywhere. Applied minus friction equals MA. No, we said we're trying to find A. Hey, how would I get the A by itself? More specific. Divide by the mass. Is it becoming a little repetitive? I hope it's becoming part of a pattern. You're starting to see how all this kind of fits together. So we can say the acceleration is going to be the applied force minus friction all over m. Okay. The acceleration is going to be, they told me the applied, 56, minus friction is mu times the normal force. I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. So I'm going to get this. A equals 56 minus mu mg all over m. The acceleration is going to be 56 minus, what was mu? 0.24? What was m? 12? 9.8 all over 12. The acceleration is bracket 56 minus 0.24 times 12 times 9.8, close bracket, divided by 12. Did you guys get an acceleration of 2.31 blah, 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 blah? Sounds right? People nodding their head? I'll go 2.3 meters per second squared, but I'm going to use the answer button on my calculator. And now we go up here. Can you get the A by itself? You rattled it off earlier. Sorry. Yeah. I apologize for thinking you were more awake than you actually are. My bad. VF. Oh, no, we don't want to get the A by itself, Mr. Dueck. Sorry, this is why you're looking at me confused. You know what? I apologize for thinking I'm more awake than I actually am. Wow, Captain Obvious, that was right in my face. You know what? I'm going to go like this. VF squared equals VI squared plus 2AD. Devin, make fun of me. How would I get rid of a squared? Yeah, can you say square root duh? Because that should be in my face. My brain was totally elsewhere. So you're saying I'm going to do that? Honestly, I'm embarrassed. And this is going on YouTube for the world. You know, all these people that I got, several thousand subscribers. Oh, you're such a good physics teacher, Mr. Dueck. You suck, Mr. Dueck. First thing in the morning, that was like a rookie mistake. 0 squared plus 2 times 2.3 times 16. Zero squared plus 2 times, answer button, times 16. I'm going to hit equals, square root. Colin, did you get 8.6?
Yeah.
There you go. 8.6 what? Meters per second. If you got that, first of all, be proud, and that's 3 out of 3. Otherwise, boy, I would probably give you 1 mark if I saw that you got the A by itself. I would give you 1 mark for finding the A. I would probably give you a half mark for getting the V by itself, and a half mark for the answer. Last one, let's go skiing. Mr. Dueck. Yes, Max. Who drew that amazingly good picture there, Mr. Oh, thank you. I'm a little embarrassed, but I drew that. Isn't that good for me? Honestly, that's Leonardo da Vinci. For my skill level, that's as good as you're ever going to see. So the fact that you can kind of tell what that is, vaguely, be impressed. I haven't finished your report card. Just saying. Maybe not. Could be. It could be. Okay, he's got a little strap holding the hat on. There. He's going really fast. He's shushing through the. Okay, fine. What's this question want me to find? The acceleration. Okay. Well. Oh, let's use red, Mr. Dueck. What are the forces acting on this person? Gravity down. Normal force. Applied force. And is there... Oh, yeah, friction. Who's winning? I think the applied force, if I understand skiing correctly. Yes? So my equation's going to be winner minus loser equals MA. Hey, Noah, what's this question asking me to find? How would I get the A by itself? Yeah. You know what? Instead of 3 marks, I think this one really should have been worth 2 marks, but that's okay. So if I hear you correctly, you're saying is that what you're saying? You'd be right. Hey, Noah, what's the applied force according to this question? You'll have to read in the question somewhere. 110, the ski poles, right? Minus friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Right? It's going to be 110 minus 0.11. Yeah, snow is pretty slippery. Mass 47. G 9.8 all over 47. Oh, wrong one. Bracket 110 minus 0.11 times 47 times 9.8. Close bracket divided by 47. 1.26, is that right? I'll take 1.3. If you got that, oop, that's terrible. If you got that, 3 out of 3. Otherwise, I would probably go 1 mark if I saw that, 1 mark if I saw that, and 1 mark for the answer. Last one. Last one. Hey, what's the key physicsy word here? That's going to be important. What do they want me to find? I think in this case, the applied force. Saying, hey, what force do you need to move it? You know what? Really what they're saying is what force do you need to apply in order to keep this moving at a constant speed? It's the applied force. I think I'm going to do a free body diagram since they didn't give me a picture. Definitely gravity down. Definitely normal force up. Well, okay, let's do it this way. Definitely the applied force. What else? How long am I going to draw friction? Why would that be wrong?
Because you're not accelerating.
Why would this be wrong?
You're not accelerating.
Constant speed means all my forces are balanced. So if I did, and this is a hint, ask you to draw a free body diagram like this, I would be looking for both horizontal forces to be the same length. Now, in a fluke, I've drawn my verticals and horizontals the same. You could draw this like that, but then I'd be looking for friction like that, same length. Who's winning? It's a tie. In fact, Jordan, you could go straight to saying applied equals friction. It's the same argument as I made way back up here in number 1, where I said, well, winner minus loser equals M, but A is 0, so you can go straight to here. The applied force is going to be mu times the normal force, which is going to be mu mg, which is going to be 0.32 times 20 times 9.8. Oh, keep doing that. 0.32 times 20 times 9.8. Do you get 62.7? 62.7 newtons. If you got that, 3 out of 3. Otherwise, I guess in this case, it'd be 1 mark for that, 1 mark for that, and 1 mark for the answer or something. This quiz is out of, count 'em, 15? Is that right? 2, 4, 6, plus 3, plus 3, plus... Yeah, okay, 15. Seemed like a longer quiz than that. Give yourself a score out of 15, please. So looking at number 7 from the, this is from the Many Body Problems homework, right? Lesson 5. Okay. What are the forces acting on this tube? Get the obvious one. Yeah, we're good at that. What else? Definitely a normal force up. What else? Which way is this thing accelerating? To the, looking for a word that begins with R and rhymes with light. Okay, so there has to be a force that way. I don't know what it is. It's not tension. You know how I know? Because the rope's not touching it. I'm going to pause. What force is pulling this thing to the right? What?
Friction.
Devin, say it loud and proud.
Friction.
Friction. Now, I'm going to convince you of that. What if this was sitting on ice? Wouldn't you be able to yank that 12 right out and the 2 would drop straight down if there was no friction? Can you? It's friction that's actually pulling it forwards, which is weird. Usually friction's been pointing in the other, but friction can cause motion too. We just haven't dealt with many situations like that. And there is no force pointing to the left. So who's winning? Friction. Who's losing? No one. So you ready? I would then go like this. Friction is what times what? Mu times the normal force. How would I get the mu by itself? I don't know the normal force. Oh, but look. I know another force, same. You know what? So let's go mu equals ma over Fn, except what's the same as Fm? Mg. Oh, and in kind of a weird one here, turns out the masses cancel. You know what mu is going to be? It's going to be the 3.6 divided by 9.8. Yep. Because you have the acceleration. That's why they made you find the acceleration first. Okay. I like that. I'm not saying I like that question. I like a question. I'm saying I like that question because it looks very complicated, but it actually ends up being an easier equation than the one that you used to find the acceleration in the first place. And I like it because, oh, friction's pointing in a different direction than we're used to. Where was the elevator skull? Oh, yeah. Anybody get this one? I always see if someone can. Didn't try it. Didn't try it. I took this, so in the Physics 12 course, back in the 80s and the 90s, there was a provincial exam worth 50%. Woohoo! You wrote it. And then those of you that were really keener nerds, after everyone left their 2-hour exam, you had a half-hour break and then you came back into the room and there was a scholarship exam. It was an hour-long exam and all it was nasty questions. But this is what they based your scholarships on. If you scored above a certain number of points, you were guaranteed, I think it was $1,500 in 1987, which was a lot of money. By the way, do you know what the scholarship for the provincial exams is now in 2015? $1,500. They haven't raised it 1 cent. So it was a lot of money in 1987. Now it's a couple of textbooks. But that's a whole other political issue, but I'll get that on YouTube too. Okay, it says this. Draw a free body diagram showing the forces acting on the box. So a box is in a scale inside an elevator. There's the box. What are the forces acting on it? Gravity down. And a normal force. Now, which way is the box accelerating, up or down, if you read the question? I don't know. It's in the elevator. So which way is the elevator accelerating, up or down, if you read the question? So you know what? If I drew the normal force, I'd draw it shorter. There's the answer to part A. Part B then says, draw a free body diagram showing the forces acting on the elevator. Okay, oh, I just lost my pen again. It's been doing good for a while. Pause. Whew, there we go. Draw a free body diagram showing the forces acting on the elevator. So on the elevator here, oh, now it's doing this thing again. I'm not touching the screen. Okay. I'm going to come back to number 16 because right now I got some tech issues that I'm dealing with. Continue. It says, draw a free body diagram showing the forces on the elevator. Well, what are the forces on the elevator? Here's your hint. Get the obvious one. Gravity. What else? Well, it says it's slowed slightly by the emergency brakes, which drag along the walls of the shaft. Now, the fact that it's slowed suggests there's some kind of a braking force, but I don't know if the braking force is bigger. or smaller. But it tells me one more thing. It says the scale reads 210 newtons. By the way, what does the scale measure? Not mg, not Matt. What does the scale measure? So what it's telling me is the normal force on the box is 210. Normally, the box has a normal force of that much. What is the scale reading right now? So does the box feel heavier or lighter? So is this elevator accelerating down or up? So I know from that the braking force, I'll call it FB, must be smaller. It says, what's the acceleration of the elevator? 3.24. I'm losing you guys, I can kind of tell. I'm going to come back to this question because I want to start. I'm not going to finish, but I'm going to start the next lesson, and I have another take-home quiz for you. So I'm going to go for about 20 minutes into the next lesson. I'll give you a take-home quiz. We're going to finish off the next lesson, next class. I can kind of see from eyes rolling and things that people are kind of zoning out. I'll come back to this one another. Gravity. It turns out, Natalia, Sir Isaac Newton showed that all objects with mass exert a force on all other objects with mass. We call that gravity. So we have gravity here on the Earth, but as you go further and further away from the Earth into outer space, what happens to the force of gravity? Well, it gets smaller. It gets smaller. In fact, if you went to the edge of the universe, there'd be no gravity. A lot of people think there's no gravity, like just in outer space, like by the International Space Station. Actually, there is. That's a different phenomena. But the law of universal gravitation is what Sir Isaac Newton came up with. So you ready? We have said that gravity is a force that exists between the Earth and masses on its surface. In fact, kind of cool, gravity is universal. It's one of the universal forces. It exists between any two masses. This picture here shows two masses, big M and little m. You know what? If you want to, you can call this... Oh, screen's still frozen. Thank you, Mr. Dueck. If you want to, you can call this Earth. Thanks, guys. And you can call this the Moon. The Earth holds the Moon in place through the force of gravity. So here's a question for us to think about. Is the force that the Earth... because the Moon has mass as well, so it also exerts a force of gravity on the Earth. So here's the question. Compare the gravity forces on the two masses. Is the force exerted by the Earth greater? Is the force exerted by the Moon greater? Or are the forces the same? And convince me. So we have the Earth, we have the Moon. Both of them are exerting a gravitational force on each other. Who says the Earth, because it's bigger, is exerting a bigger gravitational force? Okay, got one. Who says the Moon is exerting a bigger gravitational force? Who says they're the same? Convince me. Oh, you made my day. You get a candy, my friend! Did you hear what he rattled off? What did you say? Take one. Devin, you're wrong. The forces are identical. Now, Devin, F equals what? Which one has a smaller mass? The Moon. So the Moon has a bigger acceleration. Same force, though. Same force. Hey, I'll ask you a similar question. In a head-on collision between a bus and a car, which one experiences the greater force? They're the same. So why is it that the car is often so much worse off? Smaller mass, bigger acceleration. Not the force that kills, you know. It's the acceleration that does damage, not the force. Not the force. It's the acceleration. By the way, the Moon, Justin, does exert a fairly big force on the Earth. It's enough to cause the oceans to slosh back and forth. That's where the tides are from. So it's there. We don't notice it because we grew up with it. But it turns out gravity is very, 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 very weak. You need a huge mass of the Earth for gravity to be noticeable. In fact, it's so small that although Newton said, I've come up with the equation, I'm missing one particular value and I don't know how to measure it. And it wasn't until Cavendish and other scientists, they came along and they found a way to actually measure the gravitational force of attraction between a couple of big barrels of cement, which is, it's nearly zero, but it's there. And here's what they found. They found that all over the universe, gravity, and I'm not going to use an equal sign, I'm using a little fish. That's an abbreviation for depends on. I'm going to put an equal sign in the next equation because I've got to add one more number to make it correct. But they found it depended on how far apart the objects were squared on the bottom, and the product of the masses. But something else needs to go right there. And this something else is such a small number. Newton knew it was out there, but I don't know how to find it. This is the law of universal gravitation. This is Sir Isaac Newton's, one of his gifts to physics. The law of universal gravity is equal to m1, m2, over d squared, but then to make this work in front, we put a capital G, big G, where big G is called the universal constant of gravity. It's the same throughout the universe. And big G equals, I'm going to write it out. You don't need to because it's in the type font, but it's 6.67 times 10 to the negative 11. Kyle, it's 0.00034, 5, 6, 7, 8, 9, 10, 6, 6, 7. It's really small. Gravity is a very, very weak force. It was tough to find. And I'll explain to you later on, either today or tomorrow, how he found it. But it's right there. It's on your formula sheet under this unit. If you look on your yellow formula sheet, you'll see big G equals 6.67 times 10 to the negative 11. This is what allows you, Natalia, to figure out the force of gravity between, for example, Jupiter and one of its moons, or the sun and Mars, or a black hole and something else. Example 2. Calculate the force between two 4-kilogram masses separated by 0.5 meters. The gravitational force of attraction between 4-kilogram masses, that's about 10 pounds. A couple of barbell weights. They do actually attract each other, but it's going to be big G, m1, m2 over d squared. By the way, you can use d squared or you can use r squared for radius because you kind of treat these like circles. Anyways, it's going to be 6.67 times 10 to the negative 11, 4 kilograms, divided by 0.5 squared. How many newtons of force is there between two 10-pound, 4-kilogram masses? Now, you need to practice scientific notation on your calculators if you haven't already. 6.67, and then find your scientific notation button. Don't type times. Don't type a 10. Don't type a to the power of. You're going to hit your scientific notation button. Mine is there, and that contains the 10 and to the power of. It's the X button on some of them. Anybody can't find their scientific notation button, now is the chance to ask. By the way, it is not this one here. Some of you might have a 10 to the X. That's not scientific notation, and that'll behave in weird ways that you don't expect it to sometimes. So find your scientific notation button. Everybody got it? negative 11. And then times 4 times 4 divided by 0.5 squared. And you're probably going to get an answer back in scientific notation because gravity is really, 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 really small. It's weaker than weak. It's several trillion times weaker than magnetism and electricity. You get 4.3 times 10 to the negative 9? Now you'll have to translate how your calculator says that. If you did not, now is the chance to ask and I will help you figure it out. Okay? So 4.3 times 10 to the negative 9 newtons, or 0.003456789 newtons. Gravity is a very weak force. Do you know how I know gravity is a really, really weak force? Calculate the force of gravity between the Earth and the Moon. The orbital radius of the Moon is that. Okay. It's going to be big G m1 m2 over d squared. Big G is the number, this is the constant that we have to put into this equation to get an answer in newtons. This was the one that Sir Isaac Newton said, that's that small number out there, but I don't know what it is. It's 6.67 times 10 to the negative 11. The mass of the Earth, we know, is 5.98 times 10 to the 24th. How'd they figure that out? Did they put the Earth on a scale? Actually, we'll show you how to calculate it in Physics 12. Mass of the Moon is 7.35 times 10 to the 22. All over. 3.84 times 10 to the 8th squared. Now you want to practice typing that into your calculator. Now I know, oh, hang on. I know my calculator will work typing it that way. I'm pretty sure. 6.67 scientific notation button, negative 11. 5.98 scientific notation button 24 times 7.35 scientific notation button 22 divided by 3.84 scientific notation button squared. I also know that on my calculator, I don't need to put brackets around scientific notation if I'm squaring it. Yours, you might need to. I don't. This is why I've been going on my rant about bring your own calculator, figure out how it's used, get used to it. And I get, you get 1.98 times 10 to the 20th. Okay. It's a pretty big force holding the Moon and Earth together. 1.99 times 10 to the 20th. Am I right? So yeah, okay. If you didn't, look for typos. If you still can't find it, give me a holler. I'll pause for a second here. Spencer, do you want me to look at yours or not? Yep. Okay, let me pause the video.
It's the same equation, but my type is
1.99 times 10 to the, what did I say? 20th newtons. The Moon's not going anywhere, and neither is the Earth. It's a pretty big force. Now, turn the page.